We're continuing our journey into the world of algebra, and we know that we're going to get to some pretty complicated problems as we continue to work. And so we need to start to learn some of the language of algebra, and part of that is we need to understand what exponents are. Now, you know that multiplication is just repeated addition, and mathematicians wanted to have an easier way when we had the same number being added over and over and over again so that we didn't have to write it out. And so if we had 2 plus 2 plus 2 plus 2 plus 2 plus 2, that takes forever to write out. It actually takes forever to say. So mathematicians thought, you know what? Let's find a way if we could count the number of 2's or how many groups of 2's we have, and if we just multiply it by whatever's being repeatedly added, then that becomes our multiplication. So we had the same problem when we had repeated multiplication. Well, if I had 2 being repeatedly multiplied, I don't want to write that out. It just takes too long. And so what mathematicians decided to do is they said, all right, let's take whatever the number is that is being repeatedly multiplied, let's make that our base. And then they said, let's count how many times it's actually being multiplied. 1, 2, 3, 4, 5, 6. Let's make that our exponent. So just like in multiplication, exponents are a way for mathematicians to quickly show repeated multiplication. Now, sometimes we call that exponent a power as well. Now, we can use any number that we have in our number system with exponents. So obviously we could use whole numbers, we can use negative numbers, we can use fractions, we can use decimals. Any number can have an exponent. And all you have to do is take a look at what that exponent is, and it tells us how many times that number is going to be repeatedly multiplied. So if we have 12 squared, and we always say the exponent of 2 is squared because it literally forms a square. So 12 squared is 12 times 12, which is 44. Now remember, it's repeated multiplication. It's not the addition. So you have to make sure that you multiply. And if I took that 12 by 12 and placed it into a square, it shows the measurements of my base and my height for that. Now we also have a kind of cool exponent, and that's the exponent of 3. We always say that's cubed. The reason why? Because it actually makes a cube. So the squared and the cube, we always have special names for. Other exponents, we just say to the power of 4, to the power of 5, and so on. So if we have a decimal, remember that base, which is always below that exponent, is what is being repeatedly multiplied for that. Now, sometimes we're also going to have variables that have exponents. If we have a variable, the key for us is we need to know what that variable is. And you learned that any variable, if they tell us what the variable is, it's like opening the door that shows the number that's hiding behind. So this door has a big K on it. If I open up that door, I see 6's behind that door. Well, if it's going to be k to the 4th power, I replace k with my 6 and I repeatedly multiply. Notice, again, I didn't use any multiplication signs for that because in algebra we do not use multiplication signs. But in order to show the difference between each of the 6's, I put them in parentheses. So this is really 6 times 6 times 6 times 6, which is 1,296. Now you can see that our answers get very big quickly. And when we're using exponents, the reason why is because we're always repeatedly multiplying, and that's what's making those exponent answers go so high. Now, sometimes we can have a combination of letters that go together, and we can have what is called a coefficient. So if I take a look here, this -2 doesn't have any other numbers that go with it. So I'm just going to leave -2 together. But notice I have an A, a B, an A, and an A. Well, I know all those A's have to be the same number because in a single expression, every time I repeatedly use the same letter, that letter has to have the same number hidden behind the door. So if I'm going to write this in a more efficient way, what I would do is I would pull my A's together. I have 3 of the A's. The a becomes my base, and I put the exponent of 3 with it. Now b goes by itself at the end, and notice I always put the numbers first, and then I always put my variables in alphabetical order when I have multiple variables with it. Now it was important that we did not put the 3 at the end. The exponent has to go with the variable that is being repeatedly multiplied. So this is the way that I would gather those terms, and I would put it together into its own expression. Have fun today with these exponents. They're really pretty fun, but remember, multiply, multiply, multiply. Good luck.